We'll proceed in vector, summation, and calculus. Okay, so vector, summation, and calculus, the arena where we are proceeding. Vector, summation, and calculus. And the concept is how to divide our problem in n part and then solve part by part and then sum it. If I am solving part by part, then each part must be solved through vector. So that is the concept that we are pursuing. Each part must be solved by the vector. And then part by part I have to solve, then sum it. Means divide problem in n number of parts. If adding part by part does not solve the problem, means accurately, then we make n tends to infinity. Then it should solve the problem. We have taken example why we need to make n tends to infinity, like in a section, like if I, many times we have talked about it. If I have a circle, if I have a circle and then I am trying to calculate the circumference of a circle. If I have a circle, I am trying to calculate circumference of the circle, then I will divide the circumference into n different parts. I'll divide circumference into n different parts. Then we will calculate the summation I equal to 1 to n. The circumference of, I'm trying to calculate the circumference of the circle. What is the circumference of the circle? As per the fundamental, I have to divide this into n different parts. If this is x-axis and this is y-axis, then this is from here it will start first part, second part, third part, ith part, like that n part. For each part, what is the length? To calculate the length of the each part, if each part, then I have to connect this point and this point through a straight line. Okay, these are the length of each part, straight line. So I can say summation I equal to 1 to n, length of one part or ith part, length or parameter of the ith part, which is actually a straight line. If this is the case that we are proceeding with a straight line, it will not be accurate. If I make summation I equal to 1 to n, if I make summation I equal to 1 to n, and then we sum part by part, this part, this part, this part, since these are straight lines, the result will not be accurate because I have to actually, if this is the ith part, then I have to calculate the circumference of the ith part. Circumference of the ith part, not the straight line meeting the end to end of the ith part. But if I make n tends to infinity, then this ith part will be very small, infinitesimally small. If it becomes that much small, then curved line will behave like a straight line. Then it will work. Summation I equal to 1 to n. First divide into section, and then you target, anyone should target the ith part as a vector, and then through vector. What are you talking? So like consider that this is the ith part. This is P1 and this is P2. P1, point P1. P1 can be x1I plus x2j, and this is x2I plus x2 comma y2. This is x1 comma y1. If I talk about the position vector, then this is origin. Then this is xi plus x1I plus y1j. This is x2I plus y2j. If I talk about this vector, then this will be a vector that is passing through point x1 y1 to x2 y2. Then this straight line vector equation will be x2 minus x1 I plus y2 minus y1j as per the vector. If vector is passing from 2 points, to the representation of vector will be subtraction only. Means x2 minus x1 I plus y2 minus y1j will give the this vector. That is, we can also show delta p vector. If this is p1 vector, this is p2 vector, then this is delta p vector. So delta, so I can write summation I equal to 1 to n. Summation I equal to 1 to n. Okay, parameter of the ith section, or delta p, length of the ith section. What is delta p? Delta p is the vector that connects p1 and p2. Okay, what is delta p then? Delta p is x2 minus x1 I plus y2 minus y1j, but that is same as p2 minus p1. Yeah, this is what. So p2 minus p1 magnitude, that will give the magnitude of this, and then keep adding for all. Now we'll make n tends to infinity. Summation I equal to 1 to n tends to infinity, P2 minus P1 or delta P of the ith section and its magnitude. There are many loci here, at least two things that we have been seeing here. The first thing is that radius is constant. If radius is constant and circle is moving in that fashion, then typically if radius is constant, radius is not changing. There are two things here. One thing is that, okay, one thing is that if I take Cartesian coordinate system, if this is Cartesian coordinate system, this is Cartesian coordinate system. This is x-axis and this is y-axis. If this is Cartesian coordinate system, then this is polar coordinate system, where we have a line connecting origin and the circumference. Well, this line will be along the x-axis. Then this line start moving like this. Okay, we can say this line as r square equal to x square plus y square, because the equation of the circle is x square plus y square equal to this r square, that is hypotenuse. Means this is another coordinate system. I can say x square plus y square equal to r square, where r is something else. I can say y by x equal to tan theta. If I take any point here, y by x equal to tan theta, means it will form an angle, and this angle tan theta is y by x. This leads to another coordinate system called r and theta. Why this is why you say this is another coordinate system? Yeah, I know x and y, they makes a coordinate system. I know that is Cartesian coordinate system. How you say it is Cartesian coordinate system? Because x and y are perpendicular to each other. If I have a coordinate system, its axes will be perpendicular to each other. How you say that r and theta? You say r square equal to x square plus y square. Means you have taken r as a function of x and y. Yes, anything r, anything r as a function over x and y. Function f and in bracket x comma y. It is called r. Okay, there is another, I'm saying, function over x and y, that is g. There is one function called f and there is another function called g over x and y. What is that? Tan inverse y by x. Or if I say, there is a line that is moving like this. There is a line that is moving like this all along. At any point, and at any point, if I talk about this line, at any point, if this is x-axis and this is y-axis, then x square plus y square equal to this line. If this line is r, then r square equal to x square plus y square. If it is making angle theta with the x-axis, then tan theta is y by x. Means r equal to function over x and y, and theta equal to function over an x and y. Tan theta equal to y by x, and r square equal to x square plus y square. This is what we are seeing. This, how you say a this is a coordinate system. To have a coordinate system, you must be having two components orthogonal to each other. That is required. Then only you can say it is coordinate system. If I say r and theta, they belong to a polar coordinate system, then where r and theta are perpendicular to each other? Okay, anyone would ask. I know a Cartesian coordinate system means x and y are orthogonal to each other. X and y are orthogonal to each other. If I take theta r plane, consider this is theta and this is r, then x equal to, I said r square equal to x square plus y square. Tan theta equal to y by x, means x equal to r cos theta. If someone solves it, x equal to r cos theta, y equal to r sin theta. In that fashion, if I draw x and y in theta r plane, consider this is theta and this is r, I can take it as an orthogonal component. This is orthogonal component. When theta is this and this is r is this, I have to prove theta and r is orthogonal in xy coordinate system. I can take a theta and r plane. What is x? X is r cos theta. R cos theta. If r is constant, then cos theta. Cos at when theta, this is theta. When theta is 0, then x is maximum. X, when theta is 90 degree, then x is 0. It will make a curve like this. When theta is 5, r cos theta, then x will be minus 1. Okay, if this is radius which is 0 to 1 or 0 to a, then r equal to a cos theta. When it is theta is 0, x is a. When theta is pi by 2, x is 0. It will go like this. Whereas y is r sin theta. When theta is 0, y is here. Makes sense? There are two curves here. If I draw x and y in theta are plane, this is x, this is x. At the beginning, x is like this. And at pi by 2, x touching 0. Whereas y is r sin theta. At the beginning, it is like this. How much difference they are? They are. Okay. Now, if I see, then when pi by 2, it will be maximum. Means, means they are in difference of theta degree. I'm sorry, pi by 2 degree. When theta is 0, then x is maximum. When theta is pi by 2, then x is 0. When theta is 0, y is 0. When theta is pi by 2, y is maximum. Means this proves that they are, if I draw the curve, then sinusoidal curve and cosine curve, they look similar. There is no difference in that. Means y is a sinusoidal wave and x is a cosine wave, but they are exactly same. What is the difference? Difference is of pi by 2. If I shift, if this is cosine wave, if I shift by pi by 2, it will become like this. It will exactly overlap the r sine theta. If I shift, how much you need to shift? Pi theta equal to pi by 2. Means x and y in theta are plane, they are at pi by 2 gap. Means pi by 2 means 90 degree. Means they are really orthogonal. Someone can say, can you prove that x and y, they are orthogonal in xy plane? Yes, they are orthogonal in xy plane. This is x-axis and y-axis. They are 90 degree. Can you prove this? They are orthogonal in theta r plane also. Yes. X equal to r cos theta, y equal to r sin theta. Cos theta, sin theta, if you draw the wave along the theta, there will be at pi by 2 difference. Means pi by 2 means at 90 degree difference in theta. Means they are orthogonal to the each other. Okay, whereas if I talk about xy plane, then there is an angle. Angle is going like this. This angle is, if I talk about angle, their angle is straight line. Theta is on a straight line and radius is perpendicular to it. But in xy plane, if I talk about angle, their angle will go like this. This is angle. Okay, how someone can say this angle is perpendicular to the radius? If I have a circle like this, both should be perpendicular to each other, right? If I have a circle like this, and this is x-axis and this is y, yes, I believe on your concept that x and y are perpendicular to the each other. Looks like they are. This is a coordinate system, right? Yeah. If two axes are perpendicular to each other, this is called coordinate system. But here you are drawing r and theta. You are superimposing r and theta in Cartesian coordinate system. Yes. Then this is r. R is moving like this, making theta angle. How they are perpendicular to the each other? R and theta is a coordinate system. You are saying, yeah, r and theta is a coordinate system. In x y, show me it is a coordinate system. This is r. R is going like this. Okay, theta is an angle. They are not similar. They are not similar. Okay, if this is r, to have the perpendicular, theta vector should go exactly tangent to the surface. This should be theta vector. If this is r vector, then they are perpendicular to the each other. Okay, if you someone wants this as theta vector, someone wants this as theta vector. Okay, then this theta vector is nothing but going along the arc. Going along the arc means if this angle is theta, then this arc is r into theta. Okay, means r vector and r into theta vector, they are perpendicular to each other. Makes sense? I think it's all right. R and theta, they are not perpendicular each other in the Cartesian coordinate system. If I draw Cartesian coordinate system, R and theta, they do not look like a perpendicular to each other. R and R into theta, that is the arc. That is the arc. They look like perpendicular to each other. R is going like this and theta is going like this. Oh, sorry, R theta is going like this. Means any point on the surface, any point in the surface. Can you describe r theta point in polar coordinate system inside Cartesian coordinate system? If I talk about this point and this is r comma r into theta, theta is 0, so r comma 0. This point if I talk, then this point will be R. Since from origin distance is R, and in theta it will be R into theta. If this is 45 degree, then R into 40 pi by 4. This will be R into pi by 4. R comma R into pi by 4. This will be this point. Okay, since this is arc is a line. If this is radius is a line. Along the line, this is the vector. If this is arc and arc is a line, then along the line theta vector is there. This is theta vector. This is exactly perpendicular to the radius. Means r comma r theta. R and r theta forms the orthogonal component. They are polar coordinate system. But since r and theta, r is constant, we make r constant, theta variable. So we just say that it is r and theta is a polar coordinate system. But actually it should be r comma r theta. Anyway, now we are in phase of calculating the circumference of a circle through the parameterization. If this is a circle, this is x-axis and this is y-axis. This is x-axis and this is y-axis. What is the circumference of the circle? If this is x-axis and this is y-axis, then what is the circumference of the circle? Okay, then we will take theta r plane separately. This is called parameterization. What is parameterization? Parameterization means whatever we have x and y. If I talk about any point here, x comma y, then I have a vector representation of x comma y. That is xi plus yj, xi plus yj, xi plus yj. I can write I have position vector along the curve, position vector, not the tangent vector. This is tangent vector. This is position vector. Position vector means any point connecting the origin. That is position vector. So if I talk about position vector in Cartesian coordinate system, then this is xi plus yj. This point is x comma y. This is point is x comma y. This is xi plus yj. Parameterization means can I represent our vector through single variable? What do you mean by single variable? And like theta. Okay. If I have a circle where radius is constant, then I can say x equal to a cos theta, where a is constant, y equal to a sin theta. Okay, in that fashion, xi plus yj will become a outside cos theta I plus sin theta j. This is a parametric vector. Cos theta I plus sin theta j means full is varying only with variation of theta. X and y 2 points are varying only with the variation of theta. Okay, or there can be another scenario where r varies with the theta. R varies with the theta. Right now, r is not varying with the theta. Like this is centered at the origin, then r is not varying with the theta. If r is not varying with the theta, but here r is varying with the theta. R is varying with the theta. Okay, r vary with the theta. If this is origin, and this is a circle, okay, circle, this is the radius of the circle. If this radius of circle is a, then the circle equation is x square plus y minus a, because this was x square plus y square equal to a square. If I shift it by a along the y, the equation will be x square plus y minus a whole square equal to a square. If someone settle down x equal to x equal to a cos theta and y equal to a sin theta, x equal to a cos theta and y equal to a sin theta, in x square plus y minus a whole square equal to q. If I shift this circle from this is circle centered at the origin, x square plus y square equal to a square. If I shift this circle, then it becomes x square plus y minus a whole square equal to a square. If I take y equal to a sin theta and x equal to a cos theta, then it will transform into, or r cos theta, r sin theta, r being the radius, then it will transform up and rephrase this. Okay, I have a circle which has, I'm talking about variable radius circle. Radius is varying with the angle. Okay, this is a constant radius circle. Means circle is centered at the origin. Radius is constant. Okay, if I take, how you can say radius is constant? Because this is point connecting origin and the circumference. This is radius. So radius is constant. But if I make like this, shift it up to the radius. Okay, this circle has a radius of a. So this is a. I shifted earlier. It was here. Now it is here. If this is if this is a, then equation of the circle is x square plus y minus a whole square equal to a square. Okay, x equal to r cos theta, y equal to r sin theta. In that fashion, it becomes r square cos square theta plus r square sin square theta. Okay, sin square theta minus a means 2r sin theta a equal to a square. If someone solve it plus a square, someone solve it, it becomes r square plus a square minus 2 r sin theta a equal to a square gone. Now it will become r square equal to 2r sin theta a. Will become 2a sin theta. This is variable. If I have a circle with radius a, that is true. But the equation that is coming here is r equal to 2a sin theta. Means radius is varying with the angle. How it is varying with the angle? See, this is the circle where origin is here. If origin is here, the radius means that the line that connects origin to the circumference. Here, the radius is this. Here, at this angle, radius is this. At this angle with the x-axis. This is the radius. Radius is changing with the angle. Okay, angle is going from 0 to pi, 180 degree, and radius is changing from 0 to 2a. If this is a, we decided the radius is going from 0 to 2a, and then 2a to 0 back. R equal to 2a sin theta. Means if a is 1 by 2, then r equal to sin theta. Okay, what is the circumference of the circle? If circle is centered at the origin, then radius is constant. Or circumference of the circle when the this is the equation of circle where radius is varying with the angle. Okay, for that we took two parameter. We took parameterization. Means this is xy plane, then there is a theta r plane. This is theta r plane. This is theta r plane. If r equal to sin theta, when angle is 0, then radius equation is like this. When angle is 0, when angle is 0, this is r going as a sin theta. This is phi. It is making a full arc like this. What is length of this arc in theta r plane? That is different than what is the length of this arc in xy plane. Both are different. What is difference? Here, if I talk about this sin theta, why there is a difference? Someone would ask why there is a difference. This is theta and this is r. This is r equal to sin theta. Okay, if that is the case, if I take any point here, then this will be theta comma r, x comma y, theta comma r. Any point will be theta comma r, theta comma r, theta comma r, where theta is 0 going to pi. But if I take here, if this is also theta comma r, then it will be sine wave. If this is circle in xy plane where r equal to sin theta, where the radius of the circle is 1 by 2. If r equal to sin theta, if I take this point as r, this is r in polar coordinate system, this is r, then this cannot be theta. If this is theta and r in same way, where theta is going from 0 to pi and radius is going as r sin theta, then it will draw as a sine wave only, r theta, then it will draw it, but it is not drawing as a sine wave. It is drawing as a circle, means this point is not r comma theta or theta comma r. This point is theta r comma r. That's why it is different. And theta comma r, it makes a circle. Anyway, now what is the circumference of the circle? In theta r plane, we chop this theta 0 to pi into n part. I am trying to calculate the circle circumference where r equal to sin theta. If this is theta, this is r and this is theta, it makes a sinusoidal wave, r equal to sin theta. If I chop theta 0 to n, theta is going 0 to n, I'm sorry, 0 to pi. If I chop into n part, 0, pi, sine wave, 0, pi, sine wave. This is sine wave, 0 to pi sine wave. Radius is proceeding like this. Vertical is radius. Means radius keep on changing with the theta. If I try to calculate this length, there will be different calculation. But whatsoever, we are involved in calculating the circle circumference. If I chop this theta in 0 to pi into n part, this is the ith part. This ith part, if I chop, then this will go and hit here. How it will look and that side? How it will look that side? Okay. If I cut this ith part, it will go and meet here. Okay. This is R1 and this is R2. Similarly, if I take the equivalent of that in theta r plane, if I take equivalent of that in xy plane, this is x axis, this is y axis, this is like this. We can origin at the bottom. If I take like this, then this is the radius, this is the radius, this is the radius that is going like this. At the beginning, radius is 0. And as it grows, radius is growing at 90-degree, radius is maximum. There also radius is maximum. Okay, if I now how I can cut theta into n part? I'm cutting theta into n part. If I say corresponding to theta, there is a r theta. Here we are saying r theta because these are orthogonal. Then this is r theta, that is the arc. I'm cutting this r theta into n different parts. First part, second part, third part, fourth part, like that. I'm talking about the ith part. This is ith part. If I cut this r theta, if I cut this is r theta. If I cut this r theta into n part, this is the ith part. If this is the ith part, then this is the first part, this is the second part, and this is the ith part. If this is the ith part, see the radius is changing. Radius here at the beginning of ith part, radius is r1. At the end of ith part, radius is r2. This is the arc. This is, I say, length of the ith section arc. Okay, what is this arc? If I represent this arc as a vector, if I represent arc as a vector, then length of this vector, or if this is P1 and this is P2, then this is delta P that we have seen. If this is R1 comma R1 theta, if this is R1 comma R1 theta, if that is the case, okay, R1 comma R theta, keep it as R, or R1 comma alpha. This is what many times we have said, because this is variable. Variable is very difficult to solve it, but we will go through it. Variable, okay. Or if I say this is delta P, this is position vector P1 and this is position vector P2, then this is delta P. Okay, the length of this arc in the ith section is summation I equal to 1 to n for all the arc. Summation I equal to 1 to n perimeter of the ith section, or delta P of the ith section. Okay, what we discussed in the past scenario. What is delta P? Delta P is a position vector that connects this point or this and this point, or this vector minus this vector. This vector looks like radius vector. I'm talking about all together in different coordinate system. If this is x and y, then understandable. This is the position vector. In theta r, this will be little different. But whatsoever, this is delta P. What we have seen, okay, we are talking about length vector. Length vector is a vector which represent a curved line. If I say this is a length vector, then what will be length vector? What is the coordinate system in the theta r plane? Inside xy coordinate, this is theta r inside xy. It is not pure theta r. Theta r is here. This is theta and this is r. This is theta and this is r. It is inside the xy coordinate system. What is the length vector? We have discussed in lengthy way. What is called length vector? Length vector is a vector that represents any position vector in any coordinate system, like r unit vector plus r theta unit vector. This is length vector in polar coordinate system inside Cartesian coordinate system. Okay, if this is a vector representation of any point r comma r theta or r theta comma r, then length vector, for getting length vector, I have to take out one independent component here. Now, what is independent here? Someone will say r is also changing, theta is also changing. That is true, but r is changing with the theta. So theta is main independent component. I take out theta and it will become r by r unit vector plus r theta by theta unit vector. In r theta, r is constant. So it will, if I make bracket close into theta, if I make into calculus, it will become dr by dr r unit vector plus r d theta by d theta theta unit vector bracket close into d theta into theta into d theta. Now someone would say what you said, r unit vector plus r d theta by dr theta unit vector. This is exactly same as if someone would have calculated derivative of the p. What is derivative of the p? Okay, dp by this is exactly dp by d theta. What is dp by d theta? D theta. Okay, dp by d, if p is r unit vector plus p is, I'm sorry, I'll rephrase it, I made a wrong. To calculate the length vector, if someone has vector representation, he has to take out the independent component. If I take out theta, it will become r by theta, r unit vector plus r theta by theta unit vector, bracket close into theta. If I make it calculus, means division into differentiation and multiplication into integral, it will become dr by d theta, r unit vector plus r d theta by d theta, r theta unit vector, bracket close into d theta. D theta, leave it. Whatever right now we have, it looks like if position vector is r theta, then dp by d theta is what it is. Means more or less it looks like dp by d theta into d theta. This is what is the length vector. If I talk about length vector, means vector which represents a curved line. If this is a curved line, then the curved line equation is dp by d theta into d theta. Actually it should be police p. Actually it should be p. Okay, like if this is x-axis and this is a curved straight line, what is vector representation of this? If this is x comma y, xi plus yj. If this is not a straight line and this is a curved line, what is vector representation of this curve? Then a curve y by x, everywhere it is different. If this many times I have said, if this is a curve, then y by x is variable. If I represent our vector xi plus yj in term of y by x, it will become a curve vector or length vector. That I have to take out x, I plus y by x j bracket close into x, or I plus dy by dx j bracket close into dx. This is called length vector, the vector which represent a curve. Similarly, in theta r, it will become dr by d theta, r unit vector plus r d theta by d theta, theta unit vector, bracket close into d theta. It is exactly same as dp by d theta into d theta. Okay. Now we said that what is the length of circumference? Summation I equal to 1 to n, and length of a curve that for the ith section. That is the length of a arc. What is length of this arc? Length of the length vector. That is magnitude of dp by d theta into d theta. Okay. Now what is P? P is position vector. What is your position vector? That is r comma r unit vector plus r theta unit vector. But this position vector can be in xy. You are talking about xy coordinate system. Yeah, we are talking about xy coordinate system. Then this can be coordinate system in xy. D of xi plus yj by d theta into d theta. Makes sense? What is x r cos theta? What is y r sin theta? Means d of r cos theta I plus r sin theta j by d theta into d theta. For this I have to take magnitude because this is a vector. Vector magnitude if I take and then integrate with d theta, that is delta. I'll come back again. This last video we talked about it. Now this is delta theta I. I have chopped the circumference into n part. This is the ith part. If this is the ith part, this angle is theta. This is delta theta I. If this is r1 and this is r2, r2 minus r1 is delta r. Okay, let's rephrase this. The length of the ith section circumference is dp by d theta magnitude into delta theta. It is something like delta p by delta theta I magnitude into delta theta I. What is delta p or dp by d theta? What is p? P is xi plus yj. How come you can say P is position vector. Position vector can be in r theta, it can be in xy. After all, we are doing computation over the over the Cartesian coordinate system. So it is d of xi plus yj by d theta, or d of r cos theta I plus r sin theta j by d theta. What is r? Okay, let's go with it. What will be differentiation? Then its magnitude into d theta. What is differentiation? It will be r d cos theta by d theta plus cos theta dr by d theta, or d cos theta by d theta, where theta is the angle. If I talk about the ith section, then theta is the angle from the base, or d cos theta by d theta, or into d of cos theta by delta theta I plus cos theta dr by d theta. Delta r is nothing but r2 minus r1, delta r of the ith section by delta theta I. Okay, full bracket I is the xi plus yj, plus d of r sin theta by d theta, that is r d delta sin theta by delta theta I plus sin theta delta ri by delta theta I j. If someone compute this magnitude into delta theta I, this is the length of vector that correspond to the ith section. Actually, we left midway here only. What is the length of the vector for the ith section? Summation I equal to 1 to n, and then r delta cos theta by delta theta I plus cos theta delta ri by delta theta j, put in bracket I vector, plus sin theta d delta r by delta theta, sin theta into delta r by delta theta I, delta ri by delta theta I, plus r delta sin theta by delta theta I in bracket j, its magnitude into delta theta I. This is the ith section vector. Someone has to calculate it. Someone really calculate it, then it will become like r dr by d theta. It will become r d sin theta by d cos theta by d theta. It will become r minus sin theta, plus whatsoever. It will become very big. Ith section and jth section, someone has to do square and then a square root. Okay, and delta theta I. This is for is. If I make n tends to infinity, or I would rather say we will do it again. Summation I equal to 1 to n dxi dp by d theta into d theta, or delta pi by delta theta I into delta theta I, delta pi by delta theta I. Okay, what is delta pi? Delta of p is position vector, delta of position vector, delta of xi plus yj, delta of xi plus yj by delta theta I, its magnitude, because it's a vector. We have to calculate magnitude for the distance into delta theta I. What is this? Now consider delta theta I tends to 0. How it will become tends to 0? When n tends to infinity, the chop I am making along the circumference, if this chop size is chopped, the count we have chopped this, if this is x-axis and this is y-axis, this full circumference we have chopped into n part. If n tends to infinity, each chop will have length as 0, tends to 0. With delta theta I angle for the ith section, what we are talking, this will be tends to 0. With delta pi by delta theta I, where delta theta I tends to 0, it will become dp by d theta. dp by d theta magnitude into delta theta I. Delta pi by delta theta I. Okay, we started with the actually length vector, and length vector we computed as delta r by delta theta, r unit vector, plus r delta theta unit vector, bracket close into delta theta. Okay, if this is more or less, it look like it is delta dp by d theta. If, if I have a position vector as r unit vector plus r theta unit vector, if I do dp by d theta, it will exactly become as delta r by delta theta, r unit vector plus r delta theta unit vector, provided delta theta tends to 0. Then it will be delta. So It length vector can be reconverted into delta pi by delta theta I, which is a vector, its magnitude into delta theta I, where delta theta I tends to 0. It is only possible when n tends to infinity. If that is the case, then now we have full derivative now. Summation I equal to 1 to n tends to infinity, dp by d theta magnitude into delta theta I. Position vector is in xi plus yj. This is what we have taken, where x is in r cos theta, y is in r sin theta, where r itself is a function over theta. Means more or less dp by d theta will come as function over theta or function over r theta. If I have function over theta, so function over theta, delta theta I summation I equal to 1 to n tends to infinity. It is a fit case to convert into integral calculus. Then it will become like dp by d theta magnitude d theta. Theta is 0 to pi. What is dp by d theta? P is r cos theta I plus r sin theta j, where r is sin theta, r equal to sin theta. So it will become cos theta sin theta I plus sin square theta j by d theta. Then it will become, okay, what is d cos theta sin theta by d theta? It will become cos square theta minus sin square theta, cos square theta minus sin square theta I plus d of sin square theta by d theta. It will become 2 cos theta sin theta j. If I take magnitude, it will become cos to the power 4 theta plus sin to the power 4 theta minus 2 cos square theta to minus 2 cos square theta sin square theta. And that side we have 2 cos theta sin theta whole square, 4 cos square theta sin square theta. If I settle down, it will become cos square theta plus sin cos to the power 4 theta plus sin to the power 4 theta plus 2 cos square theta sin square theta square root. It will become cos square theta plus sin square theta whole square root. It will become 1 square root 1. 1. It is 1. 1 d theta. Theta 0 to pi. Pi is the area. Where the radius is 1 by 2, pi will be the area. Anyone can calculate. If this is a circle whose radius is 1 by 2, 1 by 2, then area, then the circumference will be pi. Circumference is pi into 2 pi r. 2 into pi, radius is 1 by 2, pi only, perfect. Or if someone is want to proceed in theta r plane only, then dp by d theta will be dr by d theta whole square plus r whole square root d theta. Dr by d theta is r is sin theta, then dr by d theta is cos square theta plus sin square theta square root 1 only. Then it will be same thing. Okay, where I want to proceed now? Where I want to proceed now? I said that dp by d theta, I'm sorry, what we said? We said that if I want to calculate the ith section circumference, if I want to calculate the ith section circumference, then it is length of this vector connecting. Or if I represent this circumference as a length vector, if I know the vector representation of a circumference, then for ith section, what is its length? Its length will be magnitude of the length vector. And magnitude of the length vector itself came as dp by d theta into delta theta I, belonging to delta theta. Delta pi by delta theta I, where delta theta I tends to 0 into delta theta I, it will become dp by d theta. If delta theta I tends to 0, then this calculating the length of the length vector will become dp by d theta magnitude into delta theta I, where p we took as Cartesian coordinate system, p at xi plus yj. Can I reverse it? Can I reverse it? What do you mean by reversing it? I'll take p as polar coordinate system and down the line dp by d theta. Okay, dp by d theta, it came as dp by d theta, dp by d theta into d theta. Okay, can I think something about in reverse fashion? dp by dx into dx. Okay, what do you mean dp by dx into dx? dp by dx into dx. Can we think in this manner? Okay, after all, we have dp, where p will be in polar coordinate system divided by dx into dx. Can it come in that form? Okay, then we will have to take again two arena. One is theta r plane and one is xy plane. Here it is a circle and here it is a sinusoidal. Now what we want? We want to calculate the circumference of the circle through dp by dx into dx. Is it possible? Where p is in polar coordinate system. Is it possible? That we will talk. Okay, idea was to finish that here only, but we could not. dp by dx, dp by dx. Okay, means it looks like dp by d theta magnitude into d theta gives the give the circumference. Then looks like the circumference is actually d of p. If this we I have a position for d of p means delta p magnitude. It is like that one. Summation I equal to 1 to n and ith section what is the delta p? Delta p is the position vector or the vector that connects these two end point of the ith section. Delta p magnitude, that is the length. If n tends to infinity, that length by length I can just add it. If the actual circumference is summation I equal to 1 to n tends to infinity, delta pi. Okay, I can rewrite a delta p as dp by d or delta p by delta x into delta x, dp by dx into dx, where p is in polar coordinate system. R unit vector plus r theta theta unit vector. Will it give the solution? That is the question is coming on. Will it give the solution? Can we calculate in that fashion also? If dp by d theta into d theta, where p is in Cartesian coordinate system, xi plus yj, can I get same circumference at dp by dx into dx where p is in polar coordinate? Reverse fashion. That way we see. Please do not mind supporting us. Plus 91 is the India country code 9483160610 telephone number. Plus 91 is the India country code 9483160610 is the telephone number.